Assalamualaikum warahmatullahi wabarakatuh. Shalom Om Swastiastu, Namo Buddhaya, greeting of well-being. We are from Group 12. We'll present a major task on oil and gas logistics with the title Risk Identification and Mitigation using SWIFT method, an analysis of the pipeline leak incident in Karawang involving PT Pertamina Hulu Energi offshore Northwest Java. Group 12 consists of 3 members, myself Bayzura Syahza, Dewa, and Welly Theresia. Our presentation consists of the following parts: introduction, methodology, result and discussion, conclusion, and future research. PT Pertamina Hulu Energi Offshore Northwest Java is a subsidiary of Pertamina, which is a state-owned oil and gas company in Indonesia. It is responsible for the exploration and production of oil and natural gas in the country and also plays a role in the distribution of these resources. However, the industry presents several challenges such as safety, environmental, and economic risk, with the risk of pipeline leaks being one of the most critical issues. And this paper aims to analyze a pipeline leak incident involving PT Pertamina Hulu Energi that happened in 2019 and identify potential risks and mitigation measures using the SWIFT method. The incident itself occurred at YYA-1 offshore drilling, well owned by Pertamina Hulu Energi in Karawang. The oil spill spread from the northern waters of Karawang to Bekasi and spread to the Thousand Island of Jakarta and moved to the Sunda Strait. The cause of the pipeline leak incident at PT Pertamina Hulu Energi remains uncertain, as the company has yet to release any official findings and is only able to provide suspicion and information on their handling of the incident. The following YY diagram illustrates the key factors that contribute to the pipeline leak in general.
Health, safety, security, and environment is a critical aspect in industrial and energy sectors. This study incorporates HSSE principles in analyzing a pipeline leak incident in Karawang. Using the structure what-if technique, or SWIFT, the study will identify potential hazards and create a report to optimize safety-related activities. The observation will include all aspects and components of oil and gas distribution using pipelines. Steps of SWIFT: first, determine the system that will be observed. Second, identify potential hazards that may occur in the system using a hazard checklist. And lastly, create a SWIFT report. Here stated is the severity categories that will be used for this research. There are 4 categories. First is ruinous, crucial, slight, insignificant, and also stated the category and score for this research. Next, stated the frequency of hazard classification table, which consists of 5 categories. First, occurring often, likely, occasional, remote, and unlikely. And the description is as per stated. Next, RN method will be used in the process. Risk rating number, or RN, is a method used to calculate the overall risk value generated from hazard source, as the equation of RN equals to DPH times LO. DPH is the severity of the hazard and LO is the frequency of the hazard's occurrence. Based on the results of the risk priority map, then the recommendations for improvement are made to anticipate potential hazards that may arise in each aspect of oil and gas distribution using pipeline. The observed system in the study is the operational activities and aspects of an oil pipeline, including monitoring and maintenance, regular inspections and maintenance, testing and verifying pipeline integrity, identifying and addressing potential hazards, conducting safety drills and emergency response training, coordinating with other departments and stakeholders, and keeping records of all activities, malfunctions, and incidents. Potential hazards that may occur during the operation of an oil pipeline were identified through brainstorming and literature review, as outlined in a below table. For the next part is the risk assessment in the oil distribution process using pipelines at PT Pertamina Hulu Energi ONWJ. Here is stated the hazards, description, the severity and frequency, and also the result of the risk RN value. Moving on to the next step of SWIFT, safeguard is a proposal of recommendation used to minimize hazards that occur during operational activities. The creation of safeguard is the final step in the SWIFT report, and for the top priority with RN more than or equal to 10 are shown in the table below. First, the hazard of weather condition. Its safeguard is regularly monitoring weather forecast and take appropriate actions, installing automatic shut-off valves at key location along the pipeline, developing emergency response plans and providing training to employees, establishing procedures for shutting down the pipeline in case of severe weather, designing the pipeline with the consideration of the weather conditions of the area. Next, natural disaster. Its safeguard is conducting regular risk assessment to identify potential natural disaster hazards in the area, developing emergency response plans for natural disasters, establishing procedures for shutting down the pipeline in case of a natural disaster, installing automatic shut-off valves at key locations, mapping out evacuation routes, and ensuring that employees know how to safely evacuate the area. Next, for human interference, its safeguards are installing surveillance cameras and monitoring systems along the pipeline, implementing security protocols and procedures such as background checks, and establishing procedures for reporting and responding to incidents of vandalism, sabotage, or unauthorized access, and providing training to employees on how to identify and report these incidents, conducting regular security audits and assessments to identify vulnerabilities and implement appropriate safeguards, and creating a system of access control and security. For free span, its safeguards are regularly inspect for any sign of stress or damage on the pipeline, use advanced technology such as ultrasonic to detect free span and take action before it causes damage, monitor the pipeline for any unusual movements or vibrations, implementing procedures for maintenance and repair of free span areas as soon as they are detected, and conduct regular hydrodynamic analysis of the pipeline to detect and predict free span issues. And for degraded or corroded pipelines, its safeguards are regularly inspect for any sign of corrosion, use advanced technologies such as corrosion coupons, ultrasonic, and cathodic protection to detect and prevent corrosion, implement procedures for maintenance and repair of corroded areas as soon as they are detected, monitor the pipeline for any unusual pressure drop or leaks, and lastly, conduct regular corrosion mapping of the pipeline to detect and predict corrosion issues. For the overpressure or overloading of pipelines hazard, its safeguards are use pressure regulating valves to control and monitor pressure, implement procedures for regular testing and maintenance of the pipeline, have emergency response plans in place in case of overpressure situations, train workers to recognize and respond to overpressure situations, and have automatic shut-off valves in place to prevent overpressure. Inadequate or outdated technology and equipment, its safeguards are conduct regular testing and maintenance of equipment and technology, continuously monitor and evaluate the performance of equipment and technology, keep equipment and technology updated with the latest industry standards and advancements, implement procedures for the proper use of equipment and technology, and regularly train workers on the proper use and maintenance of equipment and technology. For air quality hazard, its safeguards are implement procedures for regular monitoring of air quality, use advanced technology such as air quality sensors to detect and prevent air pollution, regularly train workers on the proper use and maintenance of equipment and technology to prevent emissions, have a plan in place for emergency response in case of air quality incidents, and lastly, continuously evaluate and improve air quality management systems to reduce emissions and pollutants. For soil quality, its safeguards are regularly monitor and test soil quality in the surrounding area of the pipeline, implement procedures for immediate response and cleanup in case of contamination or erosion, use advanced technology such as soil sensors to detect any potential contamination or erosion, train workers on proper handling and transportation of materials to prevent contamination or erosion, and lastly, regularly review and update emergency response plans and procedures to ensure an efficient response in the event of a soil quality incident. Noise pollution for workers. Its safeguards are use noise cancelling technology and soundproofing measures to reduce noise pollution, train workers on the proper use and maintenance of equipment to minimize noise pollution. And lastly, the hazard of ecological impacts. Its safeguards are conduct thorough environmental assessments and impact studies prior to pipeline construction to identify and minimize potential ecological impacts, and also regularly monitor and assess the ecological impacts of the pipeline operation and take corrective measures if necessary to minimize or mitigate any negative effects. Next will be explained by my friend Welly.
Okay, that brings us to the end of the discussion. To quickly recap, I'd like you to remember these key points. The SWIFT method is effective in identifying hazards in an oil pipeline system and provide recommendations to minimize these hazards. The incident of pipeline leak at PT Pertamina Hulu Energi ONWJ in Karawang in 2019 was suspected to be caused by pressure anomalies. To prevent similar incidents in the future, the company should implement safeguards such as pressure regulating valves, regulator testing and maintenance, emergency response plans, worker training, and automatic shut-off valves. Also, the company should conduct environmental assessment and regularly monitor ecological impacts. Future research should involve collaboration with the company HSSE division and use advanced methods such as hazards and incidents booting. Transparency with the public about the cause of incidents is also recommended for PT Pertamina Hulu Energi ONWJ. Therefore, the future research are the first. Future research should collaborate with the HSSE division of PT Pertamina Hulu Energi ONWJ and explore more advanced methods such as hazards, incident booting, inventory analysis, or other HSSE assessment methods. In the second, PT Pertamina Hulu Energi ONWJ should be more transparent with the public about the cause of incidents to promote trust and understanding and provide valuable information. Therefore, the future research are the first. So this is the reference that we use to do this analysis. That's all about our presentation. If there's any problem, please let us know by email on the description box, and we would like to apologize. For all your kind attention, thank you, and good morning, good afternoon, good evening, and good night.